Hi guys, in my first part we discussed the relation between classical and quantum mechanics and a little bit of history about the classical and quantum mechanics. Now my wish to study the instead of separately dealing with the classical and quantum mechanics with a comparable study. With the comparable study of the classical and quantum mechanics gives the many ideas to us, and this is the if we study like this comparing with the classical and quantum mechanics, we are going to be learn about the exact difference between the classical and quantum mechanics and the transition point. Already told that transition point where actually classical is turns to quantum mechanics, and what are the importance of the classical one and what are the importance of the quantum one. We are going to be understand by doing like this. So this is my one type of new experiment. I don't know I will success. I will get a success in this experiment or not. I got to, but my wish to simply study it that at a time we are going to be discussing the things regarding the classical and quantum one. First, you will see that a classical one in the year of 1687. In the year of 1687, Newton had came. See guys, you already know about the famous three laws of Newton. First law of Newton, second law of Newton, third law of Newton. So first law is nothing but a body remains to be rest, or body remains to be uniform motion until an external force act on it. This is first law. And second law is nothing but the rate of change of angular momentum is nothing but a force. This is second law. And third law is nothing but this is the famous law. Even everyone knows that you use day-to-day life also. If you have, and there is a opposite force, equal and opposite force. That is the famous law. You know that already. And these are the laws first given by Newton. So he made that Newton is the founder of classical mechanics. So that is also not a wrong statement. You may tell like that. So at a time in quantum mechanics, Faraday had came. So Faraday given a nice idea about the cathode tube. Cathode tube is the one type of the tube. With the help of that tube, he told that negative radiation. He created a negative radiation. These are nothing but electrons. Okay, this is the history about the both quantum and classical one. So after that, in the year of so Newton given these three laws, and Faraday also at a time. Faraday also after that he contributed this one. But there is a Einstein is there. I don't know. There is some confusion is there about Einstein. Where you want to study him? Either a special Einstein given a special theory of relativity. That is the famous law. You know that. That is the imaginary world. Special theory of relativity is nothing but one type of imaginary world. With the help of that one, we can able to move with the time travel. You know that there is many movies had came like Interstellar. These all are depend upon the Newton's this Einstein. That is special theory of relativity. And even he got a succeeded in that theory, but he won't get unfortunately he won't get a Nobel Prize for that one. He got a Nobel Prize for the photoelectric effect. Keep in mind, somewhere in competitive exam they will ask like that also. For which experiment Einstein got a Nobel Prize? Even though compared to the photoelectric effect, a special theory of relativity is popular and it is more useful but he got a photoelectric. He got a Nobel Prize for the photoelectric experiment. So, because there is a reason is also there for that, because here we can't give any proof to the government for the this one special relativity of theory. You can't give any material proof. You can just tell that, but you can't give. You cannot able to give time is travel. You can't go with the speed of light. So government ask a proof. Yes, government also know that theory is very popular and is good only. But government ask at that time what proof. So government not that government. I don't know which government is there at that time. Is not given a Nobel Prize for this experiment for our Einstein's to our Einstein. So my point is simply where you want to study in which field. Either you will take that special relativity of theory in a quantum field, or you can take that relativity special relativity of theory in a classical field. Where you will choose, because Einstein is special theory of relativity nothing but not as simply he corrected a classical mechanics. He simply he simply changed some things about the classical mechanics. He told that, and Newton is also correct. Newton laws are also correct, and everything is there in the classical mechanics. Everything is really fine, but he just given that all for the low speed velocities, low speed that are applicable for the low speed. He just corrected that these are applicable to the high speed. In case of high speed, these are not applicable, because he told that in case of high speed, time will also changes. So the only that much correction is did by our Einstein. But you cannot get this theory of special theory of relativity. You won't take in the quantum mechanics for that purpose. So it is wrong. Even though he given that much idea, yes, he given that he told that these are applicable to the low speeds. Yes, classical mechanics is fine. It is good only. There is nothing correction is there. That is fine for the low speed only, not for the high speed. That much only told by our Einstein. So even though Einstein corrected that, so you cannot study this relativity of theory in a quantum field. So even though we study this theory of relativity in a classical only. So I think that is the transition point of the classical and quantum mechanics. So there is a still little bit confusion is there. This special theory of relativity is either come under classical mechanics or quantum mechanics, like that. So in many authors refers that classical mechanics you can study the quantum special relativity of theory in classical only. So some authors will tell that no, this is the beginning point of the quantum mechanics. So this is related to the modern physics. So you can study you can take this class theory of relativity under a modern physics also. So like this is there, and keep in mind guys, in classical mechanics is there energy. First Newton came and he given such a nice 3 laws. Then for that afterwards Lagrange had came. You know that Lagrange. I will discuss about the Lagrange Hamiltonian in further videos. And just you want to know in this video what is the main idea about what is the basic idea about the classical and quantum theory. That's it guys. And some things are there. So I know that in that one, energy, Hamiltonian and angular momentum. See, energy, Hamiltonian, angular momentum. Conservation of energy knows that energy neither be created nor be destroyed, and Hamiltonian and angular momentum. And these laws are there: energy, conservation of angular momentum, conservation of energy. These whatever laws are there, this will be same in both classical mechanics and quantum mechanics. Keep in mind this. So in quantum, is it not disproved? Whatever they had, our ancestor scientists told that conservation of momentum, conservation of energy, everything will be same in our quantum mechanics is also. So this is the main pillar of our classical and our quantum mechanics. That's it, guys. So Einstein only, keep in mind, Einstein only give an idea about the time and space. Time and space is nothing but whenever you go in the high speed about the near to the velocity of the light, that is 3 to 10 to the power of 8 meter per second, there is a difference in the time and space. In our ancestor, Newton take only 3 coordinates: x, y, z. These are called reference coordinates. With the help of that one, you can able to get the position of the any object. But our Einstein told that no, there is another coordinate is also there. We can take that is the 4th coordinate as a time. That's it. Only this much he modifies this much only. After that, Einstein again studied in a quantum field. He given a photon that he will going to be studied in further years. So this is the basic idea. So from this one, my intention is just